Hello everybody and welcome to Chapter 3. In this chapter we're going to talk about probability topics, including mutually exclusive events, independent events, two basic rules for probability, contingency tables, tree diagrams, and Venn diagrams. My job here is to fill in some of the blanks that are left with the publisher video in order to give you a little bit of an outline and to remind you of some of the topics and some of the assignments that will be due under this subject. In this case, by Monday of the third week, you should have completed the Canvas quiz number 1, the Chapter 2 web assigned homework. And by Friday of the third week, you should have watched this video lecture along with the publishers and complete the Lecture 3 form for attendance. Well, before we start, one thing that we're going to have to do when we're talking about probability is define a few terms. People might have a general idea about the way probability works, but it's important for us to understand what this terminology means because there's a lot of probability terminology that is used in future chapters that's really important for us to establish now. So let's start with this. When we talk about the word an experiment is a is when we conduct an experiment, we have a measurable outcome. For example, if we roll a single die, this counts as an experiment. That's a good idea of what we mean by experiment. For a sample space, we think about all of the possible outcomes from an experiment. So in our example of a single die, the sample space would be the 1, 2, 3, 4, 5, and 6 that we would get from rolling the die. Of course, outcomes are the most basic possible results or observations from an experiment. So some notation that we use the letter P to represent our probability, and we might use capital letters A, B, and C, and so on to represent specific events. When we write P of A, where P is outside of a parentheses and inside the parentheses is the letter A, we're saying the probability of event A occurring. So for example, an event in our dice might include rolling a 3, or we could have a number of outcomes that make up our event. So event B could be what it would look like if we had an even number, right? And there's 3 even numbers. So probability, we would say, well, what is the number of favorable outcomes to the total number of outcomes? Well, in the example of rolling our dice, the probability of event A, that is, the probability of rolling a 3, is 1 out of 6. And we write that as a fraction, 1/6. Or we can give a decimal, and for probability of event B, there are 3 even numbers out of 6 faces, giving us a probability when we reduce the fraction, which we always should, of 1/2. Well, there's 3 basic rules for computing probability that you should know. One method of computing a probability is called a relative frequency approximation. That is by experiment. So if we conduct or observe a procedure and count the number of times event A actually occurs, we base these actual results, and we call this probability of A as follows. If we take the number of times that a certain event A occurs divided by the number of times the procedure was repeated. So you think about, for example, survey takers being the type of people that would end up getting relative frequencies based on a number of observed instances of an object happening. Another rule that we use for computing probability is called a classical approach, and that is one where we assume that the events, that the given procedure N has N simple events, that each of those simple events has an equal chance of occurring. If an event can occur in S number of those N ways, then we say the probability of event A is S over N. We computed our dice experiment, for example, in the opening screen. That was an example of the classical approach to probability. Those are the 2 major ways of getting a probability. Of course, a third is called a subjective probability. And this is the probability of an event A is used by using knowledge of the relevant circumstances, and it's based on experiments experience. When weather is predicted, for example, that's an example of using a subjective probability. Some rules about probability that you should know. First of all, anytime you compute a probability, that number has to be a fraction or a decimal with a value given between 0 and 1. We say if a probability of an event happening is 0, that means it's impossible. So if we roll a single die and we want to roll a 7, well, there's only 6 faces, the probability of us rolling a 7 is 0. Now, the probability of an event that is certain to happen, we call that 1. Every other probability is going to be somewhere between 0 and 1. So we say that, and this is the basic rule you have to know, the probability of event A, of any event A, is always going to be between 0 and 1. One other type of result that you should know is called a complementary event. The complement of an event, denoted by A with a little line over it like this one, A bar, consists of all the outcomes for which A does not occur. The probability of event A and its complement add up to give us a total of 1. Real quick example. Let's consider the event of rolling our die. And let's say that event A, hold on, let's get the pen going here, pardon me. Let's say that event A is the event of rolling a 3, as we said before, right? Well, we said that the probability of event A was 1 out of 6. What if we ask, what is the probability of us not rolling an A? Well, its complement would be 1 minus 1/6 by this rule, which would be 5 out of 6. What is event not A, its complement? Well, event A is a roll of our die that includes anything but a 3. So if we roll a 1, a 2, a 4, a 5, or a 6, there are 5 ways that that could happen out of a total of 6 faces, so 5 out of 6. Okay, more to come in a minute.